the number that turned belief into calculation. For most of history, belief was personal. You trusted stories, people, and tradition. Then a number appeared that changed what trust meant. To understand how belief became calculation, we have to return to a time when certainty came from authority. Knowledge was accepted because it was spoken by elders, written in texts, or repeated often enough to feel true. Belief lived in narrative, not measurement. This mattered because disagreement had limits. Competing beliefs could coexist. Truth was negotiated through culture, faith, and experience. Proof was social, not numerical. The validation of a claim depended on the community that received it, and the strength of a belief was measured by the depth of its acceptance rather than by any formal test of its accuracy. Then probability entered quietly. It did not announce itself as a revolution in how truth would be determined. It arrived as a modest tool for reasoning about games of chance, a mathematical curiosity that seemed far removed from the serious business of belief and knowledge. At first, it was a way to reason about games and chance. Dice, cards, uncertainty. It did not challenge belief. It simply described risk. But once it proved useful, its reach expanded. Probability offered something new, a way to compare beliefs without arguing about meaning. Claims could be weighed. Competing explanations could be evaluated not by arguing about which one sounded more convincing, but by calculating which one was more consistent with the observed data. Confidence could be quantified. The degree to which one should believe a claim could be expressed as a number, and that number could be updated as new evidence arrived. This was a profound shift in the nature of belief itself. Instead of asking who was right, people began asking how likely something was. This shift was subtle but powerful. Belief no longer needed certainty. It needed odds. A claim did not have to be true. It only had to be probable enough to act on. This lowering of the threshold from certainty to sufficiency was one of the most consequential shifts in the history of decision-making, because it allowed action proceed in the absence of the complete knowledge that had previously been considered a prerequisite. Trust moved from conviction to calculation. The personal dimension of belief, the sense that one had arrived at a conclusion through one's own experience and reflection, was gradually replaced by a reliance on numerical processes that operated independently of individual judgment. Over time, this changed how decisions were made. Medicine, finance, and policy stopped asking what should happen and started asking what was most likely. Numbers replaced narratives as the basis for belief. This was a turning point. Belief became something you could compute. And once belief could be calculated, it could be optimized, traded, and automated. Truth did not disappear, but it stopped being required. As probability spread, it quietly redefined what it meant to be confident. Certainty was no longer required. Action could be justified by likelihood alone. Even partial belief became enough to move forward. This felt rational. Decisions became defensible. Risk could be managed instead of feared. Instead of arguing endlessly, people could compare numbers and choose the option with the highest expected outcome. Belief became efficient, but something was lost in translation. Probability does not explain why something happens. It only estimates how often. Meaning was replaced by expectation. The question of what a phenomenon signified, what it revealed about the nature of the world, was displaced by the question of how frequently it occurred and how reliably it could be predicted. Understanding gave way to confidence intervals. This mattered because belief shapes behavior. When belief became numerical, behavior followed the math. Low probability harms were dismissed. Events that fell below a certain numerical threshold were treated as though they did not exist, regardless of the severity of their consequences if they did occur. The probability of harm became more influential than the magnitude of harm in determining how much attention a risk received. High probability benefits were pursued, even when consequences were uneven or delayed. Over time, people stopped asking whether a belief was justified and started asking whether it was statistically supported. Disagreement turned technical. If the numbers disagreed, so did trust. Authority shifted to whoever controlled the model. The power to define what was probable, and therefore what was believable, became concentrated in the hands of those with the technical capacity to build and operate the mathematical frameworks that produce the numbers. This created distance. A belief could be supported by data and still feel wrong. Experience could be overruled by averages. The language of probabilities sounded calm. Even when outcomes were severe, the conflict was subtle but deep. Belief had gained precision, but lost grounding. And once belief could be defended with numbers, it no longer needed understanding to survive. The conflict reached its peak when probability began deciding outcomes without consent. Policies were justified by expected value. Lives were weighed against likelihoods. Decisions felt reasonable on paper and unbearable in practice. This is the emotional breaking point. People were told the risk was acceptable, even when they bore the cost. Harm was explained as statistically unavoidable. Responsibility dissolved into percentages. When a harm was described as a statistical inevitability, rather than a failure of judgment, accountability became diffuse and abstract. The individuals affected by the outcome had no mechanism for challenging a conclusion framed in the language of probability. Mathematically, nothing was incorrect. The calculations were sound. But probability does not experience consequences. It cannot feel loss, regret, or injustice. When belief became calculation, empathy struggled to keep up. What made this especially dangerous was scale. At large scales, probability works well. Patterns emerge. Predictions improve. But individuals do not live at scale. They live in singular outcomes. For them, probability collapses into certainty after the fact. This created a fracture in trust. Systems insisted they were rational. People felt ignored. The more decisions relied on likelihood alone, the more detached they felt from those affected. The mathematical elegance of the calculation masked the human reality of the consequences, creating a persistent gap between the rationality of the process and the experience of the outcome. The conflict was no longer about evidence. It was about legitimacy, about whether belief justified by numbers was enough to command acceptance. And for many, the answer quietly became no. The resolution begins when probability is returned to its proper role, not as a replacement for belief, but as a lens for uncertainty. Numbers can inform judgment, but they cannot substitute for it. This shift changes how belief is handled. Likelihood is acknowledged, but so is impact. Low probability harm is no longer invisible. High probability benefit is weighed against who bears the cost. Calculation is paired with responsibility. The deeper insight is restraint. Probability is powerful precisely because it is limited. It describes patterns across many cases, not meaning within a single life. When that boundary is respected, trust can recover. Belief does not have to reject numbers. It has to refuse surrender. Numbers can guide decisions, but they cannot legitimize them on their own. The number that turned belief into calculation revealed something important. Not everything that can be computed should decide what we accept. And certainty, when it matters most, in the moments that define lives and shape futures, is not something math can deliver for us. So, what do you think? Did calculation make belief stronger, or just easier to justify? The number